Okay, so I asked you to do number 1 on the harder problems with acceleration sheet. Okay, so that's what we're going to do now. Number 1. So it says a train starts from rest and accelerates to a speed of 30 meters per second in 15 seconds. It continues at this speed until it's gone a distance of 6,000 meters from its starting point. It slows down at this point at a rate of 2 times 2 meters per second squared until it stops. So the first part is how many sections? Well, and the answer to that is there are 3 sections. So the first section is speeding up. The second section is constant speed. And the third section is slowing down. Okay, so if we go back to our question, then a train starts from rest. So VI equals 0. Accelerates to a speed of 30 meters per second. That means VF is equal to 30 meters per second. In only 15 seconds, delta T1 is 15 seconds. It continues at this speed until it's gone a distance. So continues at this speed means this VF speed becomes the VAV over here. So 30 meters per second is the VAV. Continues at this speed until it's gone a distance of 6,000 meters from its starting point. So 6,000 meters through the speeding up and through the constant velocity. So the delta D2 will be 6,000 meters minus delta D1, right? Because it says 6,000 meters from its starting point. It slows down at this point. So what's its VI? Its VI is what its VAV was. So it slows down at this point. VI is 30 meters per second at a rate of 2 meters per second squared. So A is negative 2 meters per second squared until it stops. VF is 0. How long is the train moving? How far did it go? So really we need the delta T's of each section and we need the delta D's of each section. Okay? Over here, the first thing we probably need to find before we can get our delta D is our acceleration. So we know that A is equal to VF minus VI over delta T. VI is 0, so this will be 30 meters per second over 15 seconds. So A is equal to 2 meters per second squared. Once we have that, we can now get our delta D1 because we know it's equal to VI delta T plus 1/2 A delta T squared. So delta D1 equals VI is 0, so this whole term disappears. 1/2 of 2 meters per second squared times 15 seconds squared. 2 times 1/2 is 2, 15 squared is 225 meters. So delta D1 is 225 meters, delta T1 is 15 seconds. On to the second part. So now we can find our delta D2 because our delta D2 was 6,000 meters minus delta D1, so minus 225 meters. So our delta D2 is 5,775 meters by just subtracting them. Now that we have D2 and we have VAV, we can find T2 because VAV is equal to delta D2 over delta T2. So delta T2 is equal to delta D2 over the average velocity. So T2 is equal to 5,775 meters divided by 30 meters per second. And when you do this, you get a delta T2 of 192.5 seconds. So we have our T2, our D2, our T1, our D1. Now all we're left with is the third section for the slowing down. We have a VF, and a VI, so we should be able to find T by doing A equals VF minus VI over delta T. Bring the delta T up and the A down. So delta T is equal to VF minus VI over A. VF is 0. So this is equal to negative 30 meters per second over negative 2 meters per second squared. And you get a delta T3 of 15 seconds. Once you have that, you can get your D3. Delta D3 is equal to VI delta T, 1/2 A delta T squared. Delta D3 is equal to VI was 30 meters per second times 15 seconds plus 1/2 negative 2 meters per second squared, 15 seconds squared. So 30 times 15 is 450 meters. 15 squared is 225. Half of negative 2 is negative 1, so it's going to be minus 225 meters. So delta D3 is 225 meters. Okay, so now if we look at the question, part A says how long was the train moving? So in A, you want the total time. Just add up T1, T2, and T3. T1 was 15 seconds, T2 was 192.5, and T3 was 15. So 30 plus 192.5 should be 222.5. So delta T total, 220, oops, that's not a decimal there, 222.5 seconds. Part A. Part B wants to know how far did the train go. So delta D total equals delta D1 plus delta D2 plus delta D3. So 225 plus 577.5, so that's 6,000, plus 225. So it should be, total should be 6,225 meters. C. How far did it go while traveling at constant speed? That's this one. So delta D2 is equal to 5,775 meters that we had already found. Okay, and D says, how fast is it going 12 seconds after it started? Well, 12 seconds after it started, it's still in this speeding up stage. So we can find, we know the VI in that stage was 0. It's asking 12 seconds, so the delta T is 12 seconds. And we were told the acceleration, or we found the acceleration in that stage to be 2 meters per second squared. And so you can find VF. A is equal to VF minus VI over delta T. So A delta T, the VI goes to 0 still, is equal to VF. So VF equals 2 meters per second squared times 12 seconds. VF equals 24 meters per second. Should be the answer. Okay? So that is number 1. What fun, eh? Just a few steps. But none of them complicated. The key is setting up your givens and your unknowns and figuring out what links one to the next. Okay?